Okay, in this section we're going to have a look at graphs of sine and cosine. And for what we deal with in 6D, we're only looking at graphs that have no horizontal or vertical translation. So it's really just a chance to kind of remember how things like amplitude and period, as well as the shape of sine and cosine graphs work, particularly if they've got some reflections going on. So let's get stuck into the examples. Example 7 doesn't actually ask us to draw a graph. It just says to write down the amplitude, period, domain, and range of the graph of y equals 3 sine of x on 4. So let's start with the amplitude, which is usually a pretty easy one to identify. Amplitude is just given by the size of the number in front of sine or cosine. So in this case, it's 3. The period, the rule for the period is that it's 2 pi over n, where n is the coefficient of x. So in this case, the coefficient of x is 1/4. So it's 2 pi over 1/4, which is, when we tip and times that, is 2 pi times 4 over 1. So it's 8 pi. The domain and range. Okay, so given there's no restricted domain in the rule, this kind of graph is of 3 sine of x on 4 is kind of just going to go like this and just keep going off that way. But it's also going to do the same going back the other way. So the domain will be R, all real numbers. The range is clearly not going to be all real numbers. The range is going to be determined by the amplitude, because that's how far, that tells us how far it's going up and how far it's going down. The amplitude was 3, and there's nothing moving the graph up or down. There's no constant at the end, so the graph kind of bounces up and down between +3 and -3, and so the range, could write it a couple of ways, but just say the range is equal to -3 to 3, with both of those values included. All right, example 8 asks us to sketch a graph this time, but we can actually start with a pretty similar kind of idea to what we did in the previous parts. So sketching the graph of y equals -5 sine of 3x. Even though we don't explicitly have to write it down, it's a good idea to state the amplitude, which is 5. The period will be, again, 2 pi over n, and this time n is 3, so the period will be 2 pi over 3. And the negative in front of the function gives us a reflection in the x-axis. So just to get a quick rough idea, rather than starting from the center and going up like a typical sine graph does, this will start from the center and go down. So we're going to kind of get that looking shape. And we haven't been given a domain, but we're just told to sketch it for one cycle. So we'll just keep it simple and sketch the first positive cycle of the graph. So with your sine and cosine graphs, often the easiest way to do it is to split it up into kind of quarters. So our graph will start at 0, 0. Now, if we kind of mark in, so on this grid, every 2 grid lines, I suppose, gives us sort of four quarters, 4 equal sections of our graph. We said that the graph is going to go down first, and it's got an amplitude of 5. So what's the scale we're working with here? We might make these, to fit them in, they can go down by 2s and up by 2 that way on the y-axis. And so our first point, I guess down here, a quarter of the way along the graph, is going to be at -5. Then halfway through the cycle, it's going to come back to 0. 3/4 of the way through, it's going to be back up at 5. And at the end, it's going to come back down to 0. And that will give us one full cycle. The other thing that we need to mark in is our intercepts, our x-intercepts. We knew that a full period was 2 pi on 3. And so this point here will be 2 pi on 3, 0. And this point here, well, that's just halfway to 2 pi on 3, so it's 1 pi on 3. All right, and now I'll try to sketch the curve without making a meal of it. done worse. All right. The next example, similar idea, but we're sketching a cosine graph this time. Again, don't explicitly have to do it, but it's a good idea to write down, or at the very least make a mental note of the amplitude in the period before you start sketching. So it's 2 pi over n, 2 pi over 2/3, which when we tip and times it, gives us a period of 3 pi. Okay, this time it's a positive graph and it's a cosine graph, so generally speaking what that looks like is start from the top, come down and come back up, and that would be one cycle of the cosine graph, roughly. All right, so again, let's mark in some values and try to sketch our graph. The y-axis needs to go up to 2 and down to -2, so that can be 1, that can be 2. Be -1, that can be -2. Again, we should hopefully have enough grid lines that if we go sort of every 2, that can split our graph into those sort of 4 quarters, knowing at the end it'll be, this value here will be 3 pi. All right, so let's have a look at how the graph goes. We're going to start up here. Quarter of the way through, we're going to hit the x-axis. Halfway through, we're going to be down the bottom. And then come back up here and finish where we started, because we're doing, again, just one cycle, and we've just decided to do the first positive cycle. So if we sketch this in, you can kind of see, I always find it makes it a little bit easier to sketch 1 quarter at a time. It kind of helps you get your curve looking right. Okay, so we've got 3 pi there, and just for reference, we might want to mark this value in as 3 pi on 2. For this first x-intercept, well, that's going to be halfway between 0 and 3 pi on 2. A couple of ways to think of that, but half of 3 pi on 2, if you times that number by a half, you just get 3 pi on 4. And because that's an x-intercept, I'm going to label it properly with coordinates. And then this value here, well, this value here is halfway between 3 pi on 2 and 3 pi. Couple of ways you can kind of tackle that, but if we think of, okay, so that value there was 6 pi on 4, 3 pi would really be 12 pi on 4, so halfway between those two would have to be 9 pi on 4. And so that gives us, I'll just get lazy and label it like that because I haven't got much space. 9 pi on 4 as the second x-intercept. All right, and finally, example 10. One with some sort of transformations. This one's one that's giving us 2 different rules and saying what transformations will get us from one to the other. So we're being asked to state the transformations that map the rule y equals cos of 2x to that of y equals 5 cos of x on 2. All right, so if that rule is our starting point, well, one thing that we could say is to get to the 5 in front, we would need let's write it, a dilation by a factor of 5, away from the x-axis, and that's probably the easier one to identify, a dilation by a factor of 5 away from the x-axis. The other one, or the next one, we're trying to get this 2x to become x on 2. So in other words, what we really want is we want x to become x over 4, because if we get this effect going on, that's going to cancel down to x on 2, which is what we're supposed to get to. So the question is, what is it? What sort of transformation turns the x into x on 4 and that's our dilation away from the y-axis. And remember though, this is the one where the factor kind of flips from what's in the rule. So this will be a dilation by a factor of 4 away from the y-axis, right? Because dilating by a factor of 4 away from the y-axis just turns x into x over 4 in your function. So the answer, the other parts was just for our own benefit, but this really is the answer to the question, stating the two transformations. And we've done another exercise. Good work.